Hello and welcome to Simplifying Delivery as Code with Spinnaker and Kubernetes. My name is Rob Hilton. I'm a Principal Solutions Architect with AWS, and I'm joined by my friends and peers Luis Polo, Senior Software Engineer at Netflix, and Nima Kaviani, also a Principal Solutions Architect at AWS. Today we're here to talk a little bit about continuous delivery within the context of the container orchestration ecosystem. And the short version of this is that as of right now, it's kind of hard. In order to break this problem down and understand how we can fix it, we're going to explore it in a couple of different ways. First and foremost, we're going to talk a little bit about the container orchestration ecosystem for Kubernetes, and also a little bit about Spinnaker, just so we can understand where things are. We're going to find out what's new and exciting in the world of Spinnaker with managed delivery, and then we're going to talk a little bit about the partnership that AWS has with Netflix, and the ways that we think maybe we can solve these problems moving forward together in the future and create something incredibly exciting. In order to get started with it, though, I want you to pull up your pens and your pads because there will be a quiz on this later. We're going to do a bit of a history lesson, and we're going to talk about the world of Kubernetes and Spinnaker. First things first, tackling Kubernetes. Whenever it was launched in summer 2015, it tackled things a little bit differently in terms of container orchestration software. It was focused more on creating a developer-centric interface, something that would be friendly and easy for developers to use. And it did that in a couple of different ways. Specifically, it was declarative in nature. And if you're not familiar with what declarative means, it means that you defined your end state for Kubernetes. You told Kubernetes that you wanted these applications and these network services, and Kubernetes would work on your behalf to reach that end state on its own. Additionally, because it was declarative and API-centric, the syntax was familiar to developers and operators that were used to working with cloud-centric APIs like AWS. There's also another unique, more nuanced thing about Kubernetes that made it a little bit special, and that's the fact that it was so easily extensible. It was focused on being able to abstract infrastructure bits away from operators. An example that you might be used to is if in traditional cloud ecosystems, you were allowing traffic into an application that happened to exist on a VM or instance. You were responsible for understanding how the load balancers worked and configuring everything to allow that traffic and troubleshooting it. But in the world of Kubernetes, it's designed to abstract some of those cloud provider-specific functions away, meaning you specify an API to Kubernetes, you say, give me a service, and then Kubernetes is responsible for configuring all of the control plane and data plane bits and pieces, providing the load balancers for you. Additionally, it was also extensible in the fact that you could create your own resource definitions and API structures. So you could interface with things like GitHub, for example, or Prometheus. And while your interface points with those software bits were traditionally imperative, meaning sequential, very specific, you define the how, Kubernetes allowed you to define an API that was declarative, and it would translate that into an operator model where it would interface with the infrastructure for you. In short, what all of that stuff basically means is that Kubernetes allowed itself to be friendly to both developers and traditional infrastructure operators, and provide abstractions that made everybody's lives easier, and not just one particular facet of infrastructure. Now, that said, Kubernetes isn't everything to everybody. It has some challenges, and there's a whole slew, a huge wide ecosystem of software that's grown up around Kubernetes to simplify some of those challenges for operators. One of those things is the fantastic Spinnaker, which my friend Luis from Netflix is going to talk a little bit about here.
Hey, Rob. So let me just give you a quick intro to Spinnaker. Spinnaker is a multi-cloud delivery platform, and what that means is that it supports deployments to multiple different types of cloud providers like AWS, Google Cloud, Alibaba, etc. It's open source, so if you're not familiar with it, I would encourage you to head over to GitHub and check it out. We also have a website with documentation on spinnaker.io that you might want to check out. We have a tech blog and other interesting resources there. There are two sets of features that are core to Spinnaker. The first is what we call application management, but it really is infrastructure management. And that is a way for you to manually manage our infrastructure like EC2 clusters, container clusters, etc., via a nice UI. And then the second one is perhaps the most interesting one, more relevant to this discussion here, is application deployments. So we support pipelines, and Spinnaker was one of the first continuous delivery products to put pipelines as like a first-class offering out there for software deployments. And Netflix, just to give you an idea, at the time of this writing, we had about 11,000 applications using Spinnaker with 28,000 pipelines and about 200,000 pipeline executions a day. So that's quite a bit. All right, back to you, Rob.
Okay, now that we understand a little bit about Spinnaker and Kubernetes, let's try and understand how those two things have traditionally interoperated with one another. As we mentioned earlier, traditional infrastructure orchestration was, and continues to be in some ways, very sequential. The most commonly understood example of this would be allowing traffic into an instance on Amazon EC2. You have to configure the security groups, the launch configurations, set up your auto-scaling groups, and then eventually your load balancers to allow traffic to enter your EC2 instance. As I alluded to earlier, another word for this is imperative. Sequential. I define the steps from where I start to where I finish. And then when Spinnaker came to bat to solve some of these problems, its early providers for EC2, for example, were good for solving these types of problems. A lot of the things that we need for an application are going to be similar from deployment to deployment. So Spinnaker gives operators a nice handy UI to be able to abstract some of those things away and do things repeatably in an environment like EC2. Now, pipelines took it a step further, and they allowed us to stitch together those events in sequence and also reach out to other infrastructure configurations, overlay things like optional manual definitions and steps that weren't specific to EC2 or any specific provider. And the world was happy. Or so we thought. As we mentioned earlier, Kubernetes did change some of those paradigms. All of our traditional imperative infrastructure abstraction had become declarative. In order to showcase this, let's talk about an example. Here we have a relatively flat, boring piece of YAML code. It's something that most developers and operators should be familiar with. It's a handful of API definitions. Now, by default, it's pretty bland, so let's break it down a bit and talk about some of the implications. We have an application on top, and we have Redis on the bottom. Simple. But if we break it down further, there are some implicit dependencies. We have services defined within our specific applications. Services are the way that Kubernetes applications communicate with one another. So we can interpret this as the constraint being the application for the service. The service cannot communicate with an application unless that application exists. If we take it another step further and expand, there's another implicit dependency in the fact that the application itself is dependent on Redis. But the magic to this is that I, as a developer or operator, don't have to define any of these constraints. I define all of my API definitions in whatever order I so choose. I pass them off to Kubernetes, and that's it. Kubernetes works out the order of operations and stretches itself to that end state. Declarative. So when Spinnaker started solving problems for the world of Kubernetes, its initial providers were Kubernetes were actually pretty similar to the imperative infrastructure providers we talked about earlier, in the fact that they provided a UI, they abstracted some of the more complex syntax requirements and some of the repeatability issues that Kubernetes had, and it did it very, very well. It provided a nice interface for users who didn't want to learn all the complex syntax configurations. That said, it created a problem. It meant that because Kubernetes API definitions were constantly changing, and because Kubernetes as an infrastructure tool is extensible in being able to extend the API, it meant that Spinnaker was either missing functionality that was available in either the community version of the API or the customized one, or the community was in the business of staying up to date with the Kubernetes API, which was a huge operational challenge. So V2 was introduced that changed the paradigms. Specify the Kubernetes manifest that you want to Spinnaker, and Spinnaker takes care of making calls against the Kubernetes API on your behalf. You sequence those things together using pipelines, the same as always, but you still get all the power of the Kubernetes native APIs. We're still in a bit of a strange spot, however, and that's that even though Kubernetes is powerful and it is declarative, it's what I like to call declarative in isolation. Meaning that whenever you pass manifests to the Kubernetes API, you pass them to a very specific cluster, just one cluster. So things get complicated when you're talking about multiple different clusters, or when you're talking about needing to reach out to different infrastructure components where the Kubernetes tooling to abstract that is either immature or non-existent. You also run into challenges whenever you have other infrastructure requirements and dependencies that you want to sequence into your deployment pipelines, and Kubernetes cannot be that thing for everyone. So, effectively, in short, we're in a position where Kubernetes, the provider, is declarative, but our pipelines are still inherently declarative. In short, declarative plus imperative, developer confusion. There must be a better way. Luis, help me find a better way.
All right, so let's talk a little bit more about Spinnaker and managed delivery. So Spinnaker was launched about 5 years ago. And at the time, it really changed the game for how developers and teams approached continuous delivery at Netflix and also at a bunch of other companies once it was made open source. The primary abstraction for delivery workflows in Spinnaker was pipelines, which I'm guessing you're all familiar with, if not from Spinnaker, from other similar CD solutions out there in the market or in the open source space. So with pipelines, you basically set up a sequence of steps to achieve your delivery workflows. In the beginning, everything was well and good. We had not that many apps. They were fairly simple, and so were the delivery workflows. So developers were happy. But if you fast forward to 2020, things look a little bit more like the right-hand side of this picture here. Teams are having to manage a lot more applications these days, and they are typically more complex than what they used to be as well. And even when there are similarities between the different apps, it's really hard to keep those similar apps up to date. If you're on a central team like I am, providing solutions for a bunch of developers, and you have best practices that you want to share with those development teams, it's really hard to do that too. So at the end of the day, when developers are going through this experience, they ask the question, why is this so complicated? Which leads us to a question we frequently find ourselves asking our users when they reach out for help in our support channel at Netflix, but I'm sure this happens in other places as well. And that is, what are you trying to do? In other words, what's your intent? And the intent of the user may be something simple like, I'm just trying to deploy this Debian package over to this cluster in EC2. Or it may be something like, I have this pipeline that's not working and I'm trying to figure out why. And it looks kind of complicated like this. Oh, and by the way, the guy who created this pipeline has left the company. I have really no idea what I'm doing here. At the end of the day, though, I think most developers just are trying to figure out, why are things easier? And so when we ask them specific questions about what they would like the ideal experience to be, they tell us things like, I want to store my configuration for delivery and infrastructure as code so that I can use the processes that I'm familiar with already, like pull requests and reviewing with my peers. They want someone else who's specialized in things like infrastructure and security to define the basics for those things so they don't have to worry about those. And then finally, they want to be able to easily manage many similar configs. In summary, developers want to worry more about the code that they're writing for their applications, which bring business value to the company at the end of the day, and less about how to manage infrastructure and delivery workflows. So with that feedback in mind, we envisioned managed delivery. With managed delivery, you define your infrastructure and your delivery requirements as code. So you tell us what the end state should be, and we take care of getting you there. This is, as Rob was alluding to, very similar to the concepts in Kubernetes, which switched the game from imperative to declarative. So another way of saying this is that we want to allow you to be able to specify your delivery and infrastructure requirements declaratively as opposed to imperatively. For central teams who are providing functionality for other application teams in the company, we want to allow you to be able to share best practices as code so that they can be reused by multiple teams, and to have an easy way to do that safely so that you can choose when and which teams receive those updates. Then finally, we've envisioned managed delivery from the ground up for extensibility, so that you can provide your own opinions and functionality as needed via plugins. Before I dive into some concrete examples of what this looks like in practice, I just wanted to get some definitions out of the way to set the stage. In managed delivery, an artifact is just a version software package that you want to deploy to some kind of runtime. So that could be something like a Debian package, a Docker image, an NPM package, or other types of software packages. A resource is a piece of infrastructure that you want to manage in the cloud. A spec is the definition of the details of what that resource needs to look like. So let's say you want to manage an EC2 cluster. So a spec might have things like what the type of instance would be, say M5 large, and how many of those you want, and in which regions and what accounts. The current state is the current state of that resource in the cloud at this moment, if it exists. So in the cluster example, let's say you have a cluster of 5 EC2 instances that are M5 large in US West 2 at the moment. A desired state is the state that you would like the resource to be in at all times. So in the same example, let's say you now wanted to deploy your cluster to US East 1 as well. So that would be your desired state. Environments should be pretty familiar to you. Some people call these stacks, but we went with environments for managed delivery. And what they mean are basically just logical groupings of your resources in the cloud. So things like test, staging, and prod. And then finally, constraints are just gates that control when and if an artifact version gets to be promoted into one of these environments. All right. With those definitions out of the way, here's an example of what a declarative definition for an infrastructure resource looks like. Again, a cluster example in this case. So you'll find the usual suspects within this example, things like the account where the cluster might live in, the regions where it will run, the instance type, and the capacity of the cluster. You'll notice, if you're familiar with Kubernetes, which I'm guessing you are since you're here for this talk, that this is pretty close to what a resource definition for Kubernetes looks like. And so all of the resources in managed delivery also have a header at the top with a kind, which includes an API version and some metadata. Out of the box, if you get the code from GitHub today, you get support for EC2 clusters, EC2 load balancers. We support application and classic load balancers, security groups, and then we also support Titus clusters, which are Netflix's own runtime for containers. But the interesting thing is, these are plugins, and so you can write your own to support other kinds of resources. And as Nima will tell you next, this is how we've extended managed delivery to support Kubernetes. All right, so declarative infrastructure is cool and all, but you might be asking yourself, well, isn't that solved already? Aren't there solutions out there that do this already? And you'd be right. So the AWS has CloudFormation, for example. There's Terraform. There's other types of solutions that address declarative infrastructure. The interesting thing is, once you wrap these infrastructure resource definitions into what we call delivery config manifest for managed delivery. And what that allows you to do is to define your software artifacts and link them to these resources in the cloud, and then specify the logical environments and how your artifacts should flow into those environments in your delivery workflows. And that creates a full picture of what your continuous delivery workflows look like, including your resources. So in this example here, you can see that we start with artifacts, and we have a Debian artifact defined here. So Spinnaker will continuously monitor your artifact registry for new versions of these artifacts, and we use some versioning conventions to detect when new ones become available. Then next up are environments, and in this case we have a test and a prod environment defined here. And again, environments are just a way to logically group your resources. So here we have a load balancer and a cluster in this example. And then finally, we have an example of a constraint here as well in the prod environment, and that's a depends on constraint. In this case, what that means is that an artifact version would only ever be deployed to the prod environment if it had been previously successfully deployed to the test environment. This is a pretty usual use case as well. We support other kinds of constraints out of the box, things like manual judgments and deployment time windows, with more on the radar. I wanted to touch really briefly on how managed delivery is implemented under the covers in Spinnaker, because this is another place where Kubernetes was a huge influence for managed delivery. So there is a new service that was added to Spinnaker called Keel, and at the core of Keel is basically just this monitoring loop. What it does is it constantly monitors your resources for the current state and the desired state that you've specified in your delivery configs. And if there is a difference between the two, or a delta, then we would call the corresponding resource handler plugin to resolve that drift. That's basically what happens all the time and how we keep your resources nice and happy in the cloud. Again, these are plugins, so they can be extended. All right, enough with the theory, and let's see managed delivery in action a little bit. I took the liberty of using some screenshots because I didn't want to upset the demo gods today. Okay, here's the brand new environments view. This is a brand new area of the Spinnaker UI that was added specifically for managed delivery, and it gives you an overview of your artifact versions and your environments at a glance. So on the left-hand side there, you can see your artifact versions, and on the right-hand side, your environments. In this case, you're seeing a screenshot of Keel itself being managed in production at Netflix. And you can see that we have these three environments: test, pre-staging, and main. Main being our prod environment. You can also see on the screenshot that all three of those environments at the time of the screenshot were running the same version of the artifact, version 880 there, and that they're all green, meaning that they've been successfully deployed with that version. You can drill down into a specific version by clicking on it. And once you do, then you can see exactly where that version stands across all of your environments. We also have integration with the source control system, so that gives you nice visibility into what commits from your source code relate to this specific deployment, as you can see on the top right-hand corner there. That's really useful for developers. Next, I wanted to show you what an artifact's promotion flow looks like when you have a manual judgment configured in your constraints. So in this example, I have a demo app that has two environments, a test and a staging environment. And on the staging environment, I configured a manual judgment constraint. What that means is that any version of the software will only ever be deployed to that environment once someone who has the right permissions clicks that approve button on the UI. They can do that from the UI, as I was saying, but there's a much cooler way to do that, and that's via Slack notifications. So one of the cool things that we've added to Spinnaker with managed delivery was the ability to send these interactive notifications to Slack. So not only do you get notified that something is about to be deployed and requires your approval, but you can immediately approve or reject that deployment straight from Slack. So it's pretty useful. Our users love this feature. Next up is pinning. And as the name indicates, pinning allows you to pin a specific version of an artifact to an environment so that you can bypass any constraints that have been put in place. There are two common use cases for this feature. The first being rollbacks and the second being hotfixes. So let's say that you found a bad bug in a production deployment and you want to roll back to a good version, a known good version. The way you would do that in managed delivery would be via pinning. So you would pick the version that you want to roll back to, pin it to that environment, and once you click that button, Spinnaker would automatically deploy that version without passing through any constraints. Once that version is deployed, you get the little pin icon on the left-hand side there to quickly indicate that that version is pinned. The second use case is hotfix, which is rolling forward for a fix, right? So let's say that you found a bug again and you wanted to roll out a new fix, but you don't want that to go through the usual process of test, staging, and prod. You can just pin that new version onto the prod environment and it will bypass the constraints in that case. All right, the last feature I wanted to show you is marking a version as bad. So let's stick with that example, right? Let's say you found a version that was bad and then you replaced it with a new or an older version that was good. Well, you want to make sure that you don't run the risk of accidentally deploying that bad version again. Let's say if in the future you end up rolling back a couple of versions, right? So marking as bad is how you would achieve that. You can specify a message there, and then once you hit that button, that's what it looks like on the UI. And what happens as a side effect is that we will never pick up that version for deployment again. All right. I hope that was exciting to see. I know I get super excited whenever I talk about this stuff and show, especially show what's out there in managed delivery right now, because it's truly awesome. It's really a new way of thinking about continuous delivery. The last thing I wanted to cover is extensibility again. So as I mentioned at the outset, we've designed managed delivery from the ground up with extensibility in mind. Here are the extension points that we currently support in Keel. The first one is resource handlers, and those allow you to implement your own types of resources, as I was saying earlier. Resolvers allow you to inject your opinions and smart defaults into resource specs. Constraint evaluators allow you to implement your own constraints. And then finally, artifact suppliers allow you to implement your own types of artifacts as well. So with all of these extension points, the sky is truly the limit for all the cool and new ways in which you can extend managed delivery. And so to take you on a journey of how we did exactly that for Kubernetes resources, I would like to hand it over to my friend Nima.
All right. Thank you very much, Luis. So the fundamental question to ask at this point is that if managed delivery is declarative, and if a Spinnaker is also declarative with managed delivery, and we have Kubernetes that is also declarative, can we put the two together? So based on what Rob explained, in Kubernetes, you can declaratively define what resources for your infrastructure you require. With the Spinnaker, exactly like Luis said, through managed delivery, you can declaratively define how these infrastructure resources are going to be deployed. So we have the what and we have the how. And the goal is to bring them together, right? So if you put them all together, then you'll have the full application configuration declaratively defined. And that was what we decided to do with the implementation of the Kubernetes plugin for managed delivery. So the plugin is open source, and exactly like Luis mentioned, it has extended the resolvers and the resource handlers for Keel, the microservice in managed delivery, so that it can understand Kubernetes resources. And when you supply your managed delivery configuration manifest to the platform, it understands the Kubernetes resources, interprets them, and then deploys them against your Kubernetes cluster. But before we get into how this actually works, let's start by going over how you can install it in your Kubernetes cluster. So for the installation of a Spinnaker, we use the tool called Cleat. And it's the new generation of deployment tool for a Spinnaker that allows you to have your Spinnaker deployment run in a Kubernetes cluster. You provide it with a list of configurations in a YAML document. You include information for your Keel microservice, like the persistence data store, where it's actually going to store the delivery configuration files, as well as this list of resources and plugins that you want to enable for it. Then you supply information about the Kubernetes managed delivery plugin, and then you generate the output configuration files using Cleat for all the Spinnaker microservices. Once all the output is generated, you use Customize, the customization tool from Kubernetes toolchain, to actually supply the generated resources for Kubernetes to a Kubernetes cluster. You get the generated resources, you apply them to your Kubernetes cluster, and you'll have your Spinnaker deployed with all your microservices, including the Keel microservice and your other managed delivery configurations. So once you have that, then what you can do is that you can configure a Spinnaker to work with a Git resource in a Git repository so that you can supply managed delivery configuration to it. Then when it happens that you provide your managed delivery configurations, Spinnaker pulls that information from the Git repo, stores it in the Keel data store, and then Keel starts contrasting that configuration file against your Kubernetes cluster. In case it notices discrepancies in the Kubernetes cluster, then it runs a reconciliation cycle, very similar to Kubernetes. And this is exactly what Luis also touched on. So when during the reconciliation cycle, it notices the Kubernetes resources that are missing or added or modified, and makes sure that it brings the state of your Kubernetes cluster to match what you've specified in your managed delivery configuration file. So this is the GitOps behavior through Spinnaker, right? And you may think to yourself that you've already seen similar stuff. With Argo CD or vBorks Flux, you probably have seen GitOps against Kubernetes cluster, right? There's also other CI/CD tooling, the older generation, like Go CD or Circle CI or Concourse, that would allow you to do similar stuff. But what is the difference here? Well, there are three main benefits that you can get through Spinnaker. With Argo CD and Flux, these GitOps and CI/CD tools primarily work against a Kubernetes cluster. So if you have lower level infrastructure requirements, then you can actually use Argo CD or Flux to take care of those. With the older ones, you have to do a lot more configuration to make them so that they deploy both your infrastructure resources and your Kubernetes resources. And if you want to enable GitOps workflow, then you still need to bring all the pieces together. And that makes the entire process difficult. That's where managed delivery comes into play. With the Spinnaker, in fact, it takes care of providing and setting up the resources both for your lower level infrastructure as well as your Kubernetes, right? So you can have the entire stack of your software configuration defined in one configuration file. And then it supports GitOps by nature, exactly as I explained. So with very minimal configuration, you can have everything specified in the delivery config file or in the delivery config manifest for Spinnaker. All right, so now that we've seen this, let's go and have a look at a demo where we show how the Kubernetes plugin for Spinnaker in fact works.
We keep it short and sweet. So let's start by creating a new pipeline. We call it managed delivery. So this Spinnaker deployment has managed delivery enabled already. So for the configuration, we are going to configure an automated trigger. We are going to have the type be Git. We're going to have it come from GitHub. Username is Nima Kaviani, and then the project is Spinnaker test. So we save all of this. Great. Then we add a new stage. If you have managed delivery enabled, then you'll see this import delivery config stage showing up in your deck setup. And then for the manifest path, we're going to call it summit.yaml. Save the changes. And I think at this point, we probably have everything we need. So then we move to spinmd test. This is the repo that we've configured for the delivery config to come from. We create a new file called summit.yaml, the same thing we named our delivery config on the other end. And then for the delivery config in the manifest, we're going to keep it relatively simple. You see that there is the name of the config, there is the application name, Nima K-Spin. This is the same application that I created the pipeline in. Then we have a test environment, the setup for the Kubernetes account, and then we have two Kubernetes resources. One is the service, and as you can see, the service actually has the annotation for the application. It's a load balancer and it references the Hello app, which then points to this deployment where we have one instance of the container with the image Hello Kubernetes to be deployed. We've named our deployment Spin Summit, and as you can see, we've also named the service Spin Summit. Okay, so here on this side, I have the logs for Keel rolling, and I also looking at the pod for Kubernetes in the default namespace. So with all of these defined, I am going to commit these changes, and we expect to see some actions here. You see that it triggers a git deploy, and if I roll to my Kubernetes side, you see that we have had some logs rolling. Keel has picked up the new managed delivery change, and Spin Summit has already got one instance up and running here. Okay, great. So for me to show you that you can actually update the stuff based on the changes in a GitOpsy way, we can go to the summit.yaml file, can edit it, simplest thing we can do is that we can bump the number of replicas to 2 in here, and then we commit the changes. So on this side, you see that the NuGet trigger comes in, and you see that it'll result in rolling of the logs on the Keel side, and very soon we should see that Kubernetes actually picks up those changes, and here we go, we have another instance running. So if I actually show it again, you see that we have Spin Summit having 2 instances deployed, and if I look at the service, you see that the Spin Summit actually is available here and potentially routable too. There you go. So we have Hello Kubernetes deployed using managed delivery.
All right. Now that you've seen the demo, you may wonder what's going to come next. All right. First of all, we're working very closely with the Spinnaker community to make it possible for everyone in the community to be able to deploy Spinnaker and the managed delivery service. So we're making changes to Keel to make it easier so that you can actually start using managed delivery, and particularly the plugin for deploying Kubernetes resources. We're also working on making the plugin more robust and reliable so that you can actually use it in your production environment and start deploying Kubernetes resources. Next thing that we want to do is that we want to go beyond supporting only vanilla Kubernetes resources in a managed delivery configuration manifest. We want to also supply resources for Helm and customize so that in case you have other ways to configure your Kubernetes application deployments, that can also be supported in the plugin. And as a result, you can actually more accurately use the plugin for the purposes that you have in your production environment. Last but not least, as we explained earlier, so far with managed delivery, you can deploy Kubernetes resources and you can also deploy infrastructure level resources. But we are planning to raise the level of abstraction here so that you can actually start thinking about higher level concepts in your application and let the platform decide about deploying the lower level infrastructure resources for your application. So all you need to define is what is required for your application logic and not to worry about how the platform is going to take care of the infrastructure for you. All right. So with that, I think we've covered most of the stuff for Kubernetes and its integration with managed delivery through the plugin that we've written. We encourage you to keep an open eye on what's coming next, as there's going to be a lot of interesting development in this area between AWS, Netflix, and other players in the community. And I'm sure you're going to benefit from what we're building. Thank you very much for joining, and I hope you enjoy the rest of your day. Thank you.